very good morning, students. Myself, Hetal Shah from New LJ Institute of Engineering and Technology. Today, we are going to discuss the subject probability and statistics. In this subject, we are going to discuss the topic correlation and regression. And in today's lecture, particularly, we are going to discussion about the regression. So let's start the regression. Regression is defined as a method of estimating the value of one variable when that of the other is known and the other variables are correlated. Regression analysis is used to predict or estimate one variable in terms of the other variable. It is highly variable tool for demand curves, supply curves, production functions, cost function, and consumption functions, etc. Type of the regression. So there are main two types, simple and multiple regression, and the other one is linear and non-linear regression. Simple and multiple regression. So depending upon the study of number of variables, regression may be simple or multiple. For the simple regression, the regression analysis for studying only two variables at a time is known as a simple regression. When the multiple regression is the regression analysis for studying more than two variables at a time is known as a multiple regression. Next, linear and non-linear regression. Depending upon the regression curve, regression may be linear and non-linear. For the linear regression, the regression curve is straight line. The regression is said to be linear. And for the non-linear regression, if the regression curve is not a straight line, then that is known as a non-linear regression. Here, not a first degree equation in the variable x and y, and the regression is said to be nonlinear or curvilinear. In this case, equation will have a functional relation between the variables x and y involving the terms x and y of degree higher than 1 and involving the terms of the types x square, y square, x cube, y cube, x into y, etc. Now, method of studying regression. So there are two methods, method of scatter diagram and method of least square. What is the method of scatter diagram? So the data are plotted on a graph paper by taking independent variable on the x-axis and the dependent variable on the y-axis. So each of these points are generally scattered in a narrow strip. So if the correlation is perfect, so if R is equal to 1, positive or negative, the points will lie on which is the line of regression. Here, the method of least square, and that is, this is the mathematical method which gives an objective treatment to find a line of regression. It is used for obtaining the equation of a curve which fits based to a given set of observation. It is based on the assumption that the sum of squares of differences between the estimated values and the actual observed values of the observation is minimum. Now, line of regression. Line of regression of y on x. So the regression equation of y on x is given by y minus y bar equal to r sigma y sigma upon sigma x into here x minus x bar. It is known as the line of regression of y on x. It is also written as y equal to a plus bx. This sigma y and sigma x are the standard deviation. Similarly, the line of regression of x on y. So that is the regression equation of x on y is given by here x minus x bar equal to r, when the standard deviation of x upon standard deviation of y, and into the bracket here y minus y bar. It is also written as x equal to a plus by. Now, we'll move for the regression coefficient. The slope b of the line of regression of y on x is also called the coefficient of regression of y on x. It represents in the value of y corresponding to a unit change in the value of x. So here this b, and in the suffix there is yx, so it is known as the regression coefficient of y on x. Okay, again I repeat, this symbol is known as the regression coefficient of y on x, and it is equal to this r, standard deviation of y upon standard deviation of x. Similarly, the slope b of the line of regression of x on y is also called the coefficient of regression of x on y, and it represents in the value of x corresponding to a unit change in the value of y. And this b, in the suffix there is xy, so it is known as the regression coefficient of x on y, and it is equal to r, standard deviation of x upon standard deviation of y. Now, expression for regression coefficient. So, first one is, here we know that the standard deviation of y on x is equal to what? That is r sigma y upon sigma x, right? So it is also known as summation of x minus x bar, y minus y bar upon summation of x minus x bar whole square, and regression of x on y, right? That is r, standard deviation of x upon standard deviation of y. So it is here summation x minus x bar, here y minus y bar, and in the denominator it is summation y minus y bar whole square. So this is the first expression for regression coefficient. For the second one, here again b means the regression of y on x, it is r, standard deviation of y upon standard deviation of x, it is summation xy minus summation x summation y whole by n upon, this is summation x square minus summation x whole square divided by n, right? The similar way, regression of x on y is equal to r, standard deviation of x upon standard deviation of y can represent as summation of xy minus summation of x summation of y upon n and whole by, here summation of y square minus summation of y whole square upon n. Okay. Now, for the third expression, and that is regression of y on x is equal to r, standard deviation of y upon standard deviation of x can represent summation of dx dy minus summation of dx dy upon n. This is summation of dx, summation of dy upon n whole by square root of summation of dx square minus summation of dx whole square upon n. And in the similar way, the regression of x on y can represent by r standard deviation of x upon standard deviation of y, so equal to summation dx dy minus summation of dx summation of dy upon n whole divided by square root of summation of dy square minus summation of dy whole square upon n. So these are the expression of the regression coefficient. Let's move for the properties of the regression coefficient. And the first property is the coefficient of correlation is the geometric mean of the coefficient of regression. Second property is if one of the regression coefficient is greater than 1, the other must be less than 1. Third property is the arithmetic mean of regression coefficient is greater than or equal to the coefficient of correlation. Next property is regression coefficient are independent of the change of origin but not of scale. Next property And that is the fifth property is both regression coefficient will have the same sign, either both are positive or both are negative. And the last property, that is the sign of correlation, is same as the regression coefficient. These are the property of the regression coefficient. And the last property of line of regression, or we can say linear regression. And that is, first property is the two regression lines x on y and y on x always intersect at their mean. And that is x bar, y bar. So this is the first property of linear regression. Second one is, since r square is equal to r square is equal to regression of y on x into regression of x on y, means r equal to square root of regression of y on x into regression of x on y. Therefore, r regression of y on x and regression of x on y all have the same sign. The third one is, if r equal to 0, the regression coefficient are 0. And the last linear regression property, that is the regression lines become identical if r equal to plus or minus 1. So students, these are the property of the line of regression, and also we known as the linear regression. In next lecture, we'll study about the example of the regression for the better understanding. Till that, enjoy the study and feel free to contact me for any query. Thank you.